Properties of inner product spaces. So let this be an inner product on a linear space X. So first property is called polarization identity. Polarization identity. Polarization identity. What is that? For all x, y belongs to x. Four times of we have we have four times x y inner product is equal to x plus y x plus y minus x minus y x minus y plus iota x plus I y x plus I y minus I times x minus I y x minus I y. Okay, so this is called polarization identity. Second, let x belongs to x, then xy is equal to 0 for all y belongs to x if and only if x is 0. Okay. C property is that is called Schwarz inequality. Inequality. Schwarz inequality. What is that? For x, y belongs to x, we have absolute value of inner product by square is less than inner product of xx into inner product of y. So let's see its from. And one condition is that here where the where equality holds if and only if this set x y is linearly dependent. It means if x y are dependent, equality will hold. If x y are not dependent, that means they are independent. There will be strict inequality. Okay, let's see its proof. So proof of part A is trivial. You can expand the right hand side. So proof of A is routine. Routine. Okay. So what is the proof of B? First, assume that x y is equal to 0 for all y belongs to n. Put y is equal to x. Then what will it? Because this equality is true for all y. I can take y is equal to x. Then x is equal to 0. And when this happens by definition in inner product, that means x is 0. Okay. Now conversely, Okay. So assume that conversely assume that x is equal to 0. Okay, x is equal to 0. So what is 0? So 0 y is equal to what? I can write 0 plus 0. So by linearity in first variable, I have this much one. Okay. So what I got? 0 y is equal to 0 y plus 0 y. So I can add 0 here. So this is cancel out. So 0 is equal to, okay. So this is for all y belongs to x. So this is proof. Okay. Now I need to prove Cauchy Schwarz inequality. So part C, let x y belongs to x. Okay. And consider z is equal to y x minus x y. Then what will be? I know that z will be non-negative. So we can expand it. After expanding, you will get this much, this much. The square of this, okay? X you will get minus y x y का bar you will get x y, okay? So again I can solve it. What is one thing? So minus, what will be minus? There will be x y y x plus x y का bar y. Okay. So what will be this? Y का square x. So what will this become? Y and this will be x y का square. Okay. Z into Z bar, Z का absolute value का square. Okay. So what is this? What is this? I can write this part. I can write this part x y का bar. Okay. So what is this? X y का. So then what will be this? This will be y and x y का. And similarly, what will be this? Y x y का. So one will be cancel out. So what is this? I can write this. Okay. So this is x minus y. Okay. So one I can take outside. So this is y. Okay. So what actually I have? I have this one. I got this much. This is actually non-negative. Okay. So there are two possibilities. There are two possibilities. either y is 0, if y is 0, or second possibility y is non-zero. But I know that y is always non-negative. In this case it will be positive. Okay, so case first, if y is 0, that means it, if and only y is equal to 0. Okay, and in that case xy will become 0, and what will be y is already 0. So this implies this equality, this this is actually 0, and that is equal to x y. So equality holds. So inequality holds. This implies inequality holds. Case second is that if y is positive, then we can divide the both side of 1. Dividing both sides, sign will not change, because if we divide by positive quantity, sign will not change. Dividing both the sides of 1, we get what we get. We get this x y minus xy का. Okay, so that means, what is the meaning of this? This means, and this implies, the meaning of this is same as this. Okay, so in either case, therefore, in either case, inequality is proved. Now we have to deal when the inequality holds. If x, y are dependent. Now, next, first assume that equality holds. Holds. Okay, equality hold means, that means, okay, what we have this much, this one we have only, but we have this one, we have this one, that this is actually, this is equal to this side we have taken common already, and we got that this part 0, then this z is 0. Means what was the z, our z, what was the choice for our z was x minus y. So that this implies that xy is linearly. But there are two possibilities. If y is 0, we know that if a set contains a 0 element, that is already. If it is non-zero, we can divide. We can express one element in terms of other. That means dependent. Now conversely assume that x and y are dependent, linearly dependent. That means x is of or y is of this form like that, whatever. Okay, because anyone can be zero also. That is why I'm writing. So without loss of generality, assume that y is equal to kx. We can assume and similarly it will follow. Okay. So what is that x y then? What is this? What is this? X kx. It will count. Okay. Okay. So actually, so what will be absolute value? I can write like that. X bits are non-negative. So it's now what is y that kx after kr. So that means so what is this implies okay prove it. Okay. So today is up to this.